Good day to you all. In this video I'm going to show you some experimental results of a zero transformer. So a few weeks ago somebody pointed me to documents of Vladimir Utkin, and it's on a Russian website. I will include the address in the video comments. So I looked with Google Translate, and it's very readable when translated. So what you are seeing over here is from the document potential energy, charges separation, grounding, and pulse excitation. So there he speaks of a zero transformer where you have a coil in two parts. So the L2 coil over here is in two parts. We have a clockwise and a counterclockwise, and then we have our L1 coil. So the thing is that when we look at the specifics, this will also be pointed to in the video comments to these pictures. So we see that the L2 has a clockwise part and a counterclockwise part, and the L1 is also counterclockwise in this setup. So what we first need to do for the zero transformer is put a sine wave signal on the L1. So the connections that are now made are from that document. I'm going to take them. So on the document you can see that we have the signal generator, and then we have a 100 ohm resistor going to the L1, and then we have over here the coil L2. Now in this case you see there is an uneven division, but I also tested in that one, and for videos on those experiments you can also watch the hidden videos that are linked to in the video comments of this video. So this is, for example, the other coils that I have used for those experiments. So that is one L1, and that are the different L2s, also with bifilar. So what we are going to do first is going to watch what happens when we place a sine wave signal on the L1. So I'm going to change the amplitudes of pulse, wave frequency. I'm going to there. So we go to lower. So the yellow trace that we see over here is the L1 input voltage, and the blue trace is the L2. I'm going to zoom out. So what the point is, that what you first must do if you got a situation for the zero transformer is that you need to place the L1 coil in such position that you don't have any voltage on the L2 coil. So as you can see now we don't have voltage, but when I try to move it, we immediately see that we create voltage. Also in the other direction, you can see that we have voltage. So going to place it again in a position where we have close to zero output, and therefore the reason of the zero transformer in the name. For the theories, it's best that you look into the documents. I'm only showing you my experimental results. So in the same situation that we are now, the magenta trace that you see over here is the input current. So I'm going back to pulses, and you can immediately see the difference. Need to change the trigger level. Set it lower. So again, the magenta is the input current, and as you can see we have the free oscillations in the L2, and over here we have the L1 input signal, and then what it returns after the pulse is down. As you will see in the other experimental videos, sometimes it is better that where I used a diode in there. So in the case that you will see in this picture, also linked in the video comments, I placed a capacitor in between the coil and a diode across it, so that I have a more clean input pulse. And in that case, I was even was possible to have some slightly underdamped free oscillations. As you can see in this circuit also will be linked the picture. So this is without the diode, where we have also that negative going signal, and we have ringing from on the input, and then where we have the diode across it, where we have that clean input pulse, and you can see that the waves are better in those cases. So there are so many different situations that we can have with this setup that I first was to try to make a document where I said, okay, this is what I measured, but there are so many influences that it is better that you experiment just yourself and look at the documents and see how it can help you. So I'm only giving you my experimental results, and you have to build it further from that on. So as you can see now, the L1 is the input current on L1 is this magenta input wave, and we can see the free oscillations. Now when I shortcut the L2 coil over here, so I will shortcut it, then you immediately see the influence. So I will take ramp so that it's continuously. So you can see that shortcutting that coil gives us a higher amplitude and some ringing in the input, but the output, the input current is not changing. You have to watch at the peak, so it's not changing at all. I will move the two a little bit further apart so that they are not crossing each other. Like that. Make the shortcut again. And you can see that the amplitude stays the same of the input current, even though we have a higher free oscillation amplitude. Now in this case, I don't have resonance in those two parts like I did with the setup on that one, where I did bring resonance with the two. But that you can see in the extra videos that are linked in the video comments. So the purpose of this whole setup is, as you can see, to have some influence on your output, but not to your input, so that your input doesn't notice what you are doing. And that is of course important when we want to keep resonance. Now, in difference to what we always see is that we want resonance also in the L1, but in my case, when we work with the pulses, I mostly see that it's better that you don't have resonance there, because once you go to resonance, you go to sine wave, and the whole principle of this zero transformer is based on sharp edges. So normally for the zero transformer, you should say that it works on pulses and not on sine waves, and therefore the L1 doesn't really need to have resonance. It is possible but to use it, but as you can see, the first thing that we need to do to tune it is to use the sine wave and see where we have the least amount of output. So it's contradicting to say that you want resonance in the L1 when your first base is to start with pulse with sine wave to measure the zero and then go to pulses to have output. So there will be more videos on this because it's really interesting, but this is just to start with. You can find all the links in the video comments. So thank you for watching and hope to see you in the next video.